Hello, do we have any remote listeners? You are muted. Could you please say something in Slack? Do you hear me? The sound is okay? Okay, then we start in a few minutes.
正在录制该会议。
Okay, let's start. First of all, have you handled the first assignment? Was it difficult? Have you seen that we have published the second assignment? Yeah, just a warning, the second assignment is more time consuming and considered to be more difficult. You cannot fix it in 8 hours before the deadline. So I suggest that you get started rather early. The topic for today is basically iterations, while and for. In the previous lecture, we talked about if statement. If statement is a type of control statement. What type of control statement is it? What was the name of this group of control statements that were selecting a path? Selective statements. And iterations is the other one, loops, students usually call them. And we have 2 of them in Python, while and for, and that will be the main topic for today. We will also take a look at a number of built-in library functions from the math module and the random module. But this is a program showing 2 examples using while and for. And both of them are doing the same thing. They are printing 1 to 10. In this case, this is the while statement. As long as n is less than 10, we do the following. And this is the for statement. For each integer e in this range, we do something like this. In general, we can say that while statements are used when we don't know how many iterations we will do, but we know a stop condition, while n is less than 10. If we know exactly how many iterations to do, this one is in general simpler. So the for statement, for the for statement, we know exactly we should start at 1 and we should stop at 10 and we should take 1 step in advance. So they are a bit different and we are using them in different scenarios. But let's start with a while statement. The while statement generally looks like this. We have the keyword while, we have some condition, we have a colon, and then we have the statements. And in general, as long as this one is true, we are iterating over the statement until the test condition becomes false. Then we are jumping out of this while statement and continue down here. As a flow diagram, it looks like this. We are entering the while loop. We see the test condition. If it is true, we go and execute the statements, and then we go back to the test condition as long as it's true. Once it becomes false, we are jumping out of the loop like this. So these are two examples. In the left-hand example, I'm printing 1 to 10 using while. I start by introducing a counter variable n and say n equals 1. And then as long as n is less than or equal to 10, I do the following. I start by printing n, and I'm increasing the value of n by 1. So when we are entering the first time, n is 1, n is 2, n is 3, n is 4, and it's repeated. The last time we are executing these statements, n is equal to 10. And then we are printing 10, we are increasing n to 11, and then this one will become false. And we jump to this part over here. Does it make sense? Not that difficult to understand. Here we have another example. Find the smallest n such that the sum 1 plus 2 plus 3 is larger than n. This is a typical example for when to use a while statement. We don't know how many iterations that will be needed. However, we know a stop condition when the sum is equal to larger than 100. So we are introducing two variables. S stands for the sum and n is our counter. And then as long as the sum is less than 100, we do the following. We are increasing the counter, we are adding the counter to the sum, and we are repeating like this. So the first time n will be 1 and sum will be 1. The next time n will be 2 and sum will be 3. The next time n will be 4 and the sum will be 6. And we are repeating this until we eventually get a false up here when n is large, when the sum is large enough. And then we are printing the result. The smallest n is n like this. This is a textbook example of when to use a while statement. We don't know how many iterations we need, but we know a stop condition. When the sum is larger than 100, then we should stop. Make sense? It is important that you get familiar, I would say, with this process. We are introducing a variable. This is called a counter, which we are increasing by 1 all the time. And we are, in this case, introducing a sum also. And the sum is updated in each iteration. It's the old sum plus something new in this case. If we should have added the numbers 1 plus 3 plus 5, in what way should we have changed this program? Yeah. Yeah. Rather than having n plus 1 here, we should have changed it to n plus 2. Then the first n should have been, well, we should have actually started from another value as well. We should have started from minus 1. We should have added n plus 2 here. And then we should have added the number. We should have then n should have taken the values 1 plus 3 plus and 5, and we should have added the sum over here. So this one gives the step length, how we are changing n in each iteration, and this one keeps track of the sum, and the stop condition is based on the sum. Up until now, we have had simple cases with only a while statement. But in general, for most problems, we need to combine the while statement with other statements. So in this case here, I'm combining while with if. And the problem I'm solving is straightforward. I would like to print all to less than 100. I should do the following. If n is divisible by 7, I print it, otherwise I don't do anything, and I'm just increasing n. So n will take the values 1, 2, 3, 4, 5, and in those cases where it is divisible by 7, I print something like this. Okay? do something while input is yes or lowercase or uppercase n. We should do something. In this case, do something just means print hello on the screen. But the idea is that we should do something until the input from this line is either lowercase or uppercase y. Enter y to continue or n to quit. So we are saying that the entry to start with is y, and then as long as the entry is not equal to any type of n, we do the following. We read something. If it is yes, then we print something. If it is not n, then we say invalid input. So this one will be executed when the user inputs A or B or something like this, something which is not y or n. But if it is y, we go up here again. We are repeating until the user inputs an n. In that case, we will, if the user inputs an n, we will not do anything in here. We will reach the top of the loop and recognize that this one is false, and we will jump to the done part in here. Slightly more complicated, but the basic idea is that continue the loop as long as the entry is not n in any format. If it is y, we do something. If it is neither n nor y, we say that this is invalid input in this case. This is also a typical scenario for using a while statement. We don't know how many iterations it will be. We just know that we should stop when an n is entered to the input. Make sense? Infinite loops. We have loops, and if I'm a stupid programmer, I might actually try to write a program that looks like this. While true, print hello. It will never stop. It is always true, and it will never stop. What will happen? Why?
Because the memory is full at the heap of memory.
But this program doesn't consume any memory.
I assume that like this, that will stop because you will just print out hello, hello, hello.
Yeah, we will just print out, but we are not consuming any memory. So in this case, it will just, it runs and runs and runs. And you can stop it by pushing Control-C in the terminal window, but the program just runs. In this case, however, why will this one run forever? Well, this one is true for any n. No matter what value n have, this one will always be true. It is so this one will run forever, or not forever, but almost forever. However, in this case, we start with a string, and in each iteration, we are adding hello to the string. So the string gets longer and longer and longer. And now we have your scenario now. This one will not run forever. Since the string grows all the time, it consumes memory. And after a while, you will not have enough memory in your virtual machine. So then the program will crash. In either case, they do not harm your computer in any way. It's a bit frustrating, for example, in this case, when it's all of a sudden the terminal just prints hello without stopping it at all. But just remember that you can always stop it by Control-C, or in the worst case, if you don't remember this one, turn off Visual Studio, and it will kill your Python process. Anyway, in most cases, we have made a mistake. a logical error when this occurs, but it's not harmful in any way. However, there are situations when you want to do something like this. For example, if you have an embedded system and the embedded system should just measure temperature in this room, for example. And then we turn on this device, and in the perfect world, it will run forever. It will measure the temperature every minute. So in these cases, we often have program that looks like this. As long as the program is running, we should measure the temperature every minute. Servers that are listening to clients' conversation, they also have infinite loop. They are running until someone closes them down. That means they are running without any stop at all. But in general, infinite loops is a result of a logical error, but they are harmless in most cases. In this case, when we are not consuming any memory, it will run forever. In this case, when we are consuming memory all the time, it will stop after a while. But they are harmless. Any problems with the while statement? While some condition, and it runs until, as long as the condition is true, it runs and repeats the statements inside the while statement. And of course, I didn't say it on any slide, but like in the if statement, indentation is important. The indentation here shows what is the body of the while statement. It shows which statement should be executed inside it. For example, if I push this one down here, I was moving it to the left-hand side, this one, the string, this one would not be a part of the while statement, and the program would run forever. So the indentations is important to show which statements are a part of the while statement. The for statement. It's more complicated. We are saying for each I in the following range, and the range can take up to 3 arguments. 0, 11, 2. It is start, stop, and step. I will show it later on. But it starts at this one, it stops at this one, and this is the step length, the way I is changed between each iteration. So it will start at 0 and print it. It will then, due to the step side 2, in the next iteration, it will be 2, 4, 6, and up to this one. And this one will not be included, since we are just stepping 2 steps. Make sense? Countdown from 10. I start at 10. And this is the stop point, and this is direction. I go down in this case. So in this case, the first one will be 10, 9, 8, 8. One thing you should be aware of is that the upper limit is not included, whereas the lower limit is. This is a strange Python idea. Didn't we have a similar problem with when we were cutting a piece of a string? I said you can always ask your string, give me all the characters between position 3 and 6. Then it was position 3, 4, 5, but 6 was not included in the string that you were cutting. It's the same here. The stop limit is not, the upper limit 11 is not included, whereas the lower limit is. So in this case, we start from 10, but we will not reach the stop limit here, which is what? Yeah, this one, the second one, the stop limit is not included. Always. And the variable here is called the for counter. For each I in this one, we do something. And this one decides which values I will take. So the range function generates integer sequences. It is rather powerful, and it comes in a number of different versions. The simplest one is just range stop, considers by default that the starting point is 0 and the step size is 1. So range 10, it will start with 0 and it will not reach this one. So range 10 will iterate over the values 0 up to 9. Start to stop, the one that I was showing earlier on, from start to stop -1 with step size 1. So default is step size 1. And then you have the general version, from start to stop with a certain step size. From start to stop with a certain step size. And here, 10 is not included, since we are not reaching 10 in this case. When I do some programming and I put together a for statement, I don't fill the body with anything. The first thing I do is just to make sure that I got it right. I'm printing this I value to see that it takes the values that I'm interested in, because I know that it's easy to make an error using the range function here. So I would say, think about it like this, that this is the general version. And then we have a shortcut version here, which uses the default values. And the default values is to start from 0, and to step size is just 1 positive step forward. Okay. Break and continue are 2 other keywords in Python, and they are used to interrupt a loop. They are interrupting the loop in 2 different ways. Here I have a while statement. Skip this parenthesis. It's an error from my side. It shouldn't be any parentheses in. I used to give the same lecture in Java, and then it was a curly parenthesis in here, which I didn't remember to forget. Anyway, so skip this one, skip the curly bracket. We have a while statement. We have some Boolean expression, and we are iterating over this loop body. And then if something happens, if this one is true, then we reach the command break inside the loop. Then we are ending the loop and jumping to the next statement after the loop. So we are iterating here, and when we reach break, we are jumping to this point here. We are interrupting the loop. Continue. It ends this iteration. So we are iterating here. We are reaching this part. Then we are interrupting this iteration. That means we are skipping whatever code we have down here, but we are continuing up in this point here. Do you make the sense? Do you see the difference between them? So break interrupts the entire loop statement. It also works for for statements. But however, continue interrupts the current iteration, but it jumps back to the top of the list like this. Both of them are considered to make the code more difficult. Most humans and most programmers, when they see a while statement, they see that it starts here, and then they follow the indentation and say it stops down here. They're expecting us to iterate over this loop body. We are not expecting it to be a break in the middle of it. So they are considered to make the code more difficult to understand. So if you can avoid them, try to do it. A slightly more longer example. Is it a prime number? In this case, we say that a positive integer n is a prime number if it is not divisible by any numbers in the range from 2 to n minus 1. Do you agree with this definition? You cannot find anyone that divides it. Unless it is the number 1. I, of course, write a program that checks if a given n is a prime number. The basic idea, well, first of all, some kind of error message. If n is less than 2, because then we are not using this definition. And then we are testing each value in this range. So we have a for statement iterating over all these possible values. And if it is divisible by I, then we know it's not the prime, and then we can interrupt the loop. However, if we're iterating over all this value and we don't find that n is divisible by any of these numbers, then it means that n is a prime number. When you run the program, it might look something like this. This is 3 runs. Enter an integer larger than 1, 47, and then the program responds, 47 is a prime number. Enter an integer larger than 1, the user inputs 49, then the program says 49 is not the prime number, it is divisible by 7. And then enter an integer larger than 1, we give -7, and then our program recognizes that this is not correct and say, please follow the instructions. And the instructions say integer larger than 1. Do you understand how it should work? So this is my solution. Check if input is a prime number. It's a title. So we are giving a user instruction, reading it with input, converting it to an integer n. And then if n is less than 2, we print this one. The error message otherwise. So this is where we are checking if the n is is a prime number. I start by saying prime equals true. And then I'm iterating over all values in the range 2 to up to n. Remember now that n is not included, so I'm actually iterating over all values from 2 to n minus 1. I will take all these values. However, if I find that n is divisible by I, then I said prime is false and I break, so I'm interrupting the loop in this case. If we are saying prime is false, we break, we jump here. If it is a prime, we print it's a prime. Otherwise, we are printing it's not the prime. However, if n is not the prime, we will iterate over this one until we reach I equals n minus 1. We will not update prime. So in this case, prime will be the initial value true here, and we will print n is a prime number. It makes sense. Yeah, this is a typical assignment 2 exercise. It involves a few if statements, and they are nested. We have an if statement containing a for statement containing an if statement. Most non-trivial problems involves a combination of these different control statements. If you take a look at a huge Java program, 1 million lines of code, they are solving 1 million lines of code. They are solving 10,000 small problems like this. We are doing it all the time. We have a certain functionality, and then we do a computation like this to solve a certain problem. So they are used not only in the beginner's course in programming, and this type of problems are showing up all the time when we are programming, and we must fix them in some way. Combine if, while, and for in some way to solve the problem. Yeah.
If we are requesting the user to enter a number which is larger than 1, where we are using if n less than 2.
If, well, it's the same thing. If an integer is not fulfilling this condition, then it must be an integer which is less than 2. Integer larger than 1, that means 2, 3, 4, 5, 6, 7. a condition, if this one is not fulfilled, it means that it must be 1, 0, and negative numbers. So this is the same thing to check for this one. Yeah. Any other questions related to this one? Okay. Nestle statements. In the previous case with the prime number, we have nested statement, and this one is an obvious case for using 2 for statements. We are about to print the multiplication table. Please enter a positive integer. Here I just entered 3. And the multiplication table for 3 is, and then I start to print here, all combinations with all combinations here, all possible combinations. And this is a typical nested for statement. I'm reading the integer, convert it to reading a value, convert it to an integer. If it is less than 1, I print input must be positive. Otherwise, I'm iterating. Well, let's take a look at the print statement here. For every time I'm reaching this line here, I take a first value times the x, another value equals, and then I'm compute the product of them in here. So and here I'm iterating over all possible I values. That means from 1 to n plus 1. That will mean from, in this case, it will mean that the range is from 1 to 4. And also here, the range is from 1 to 4. So it will start with I equals 1. And then it will go I equals 1. And then j will take the values 1, 2, 3. Then we are done with the inner one. Then we go one more time up here and say I equals 2. And then we go 1, 2, 3. And then we go one more time up here and we go run through them one more time. Does it make sense? So, if statement, the topic for the previous lecture, if something is due, we do it, and then we have different branches. I think it's rather easy to understand it by itself. The same holds for the while statement. We are repeating something as long as the Boolean condition is true. The for statement, slightly more complicated due to the range function, which is more complicated, but still, each one of them can be rather easily understood by itself. However, problem solving using a combination of them is much harder. In assignment 2, we have a large number of these type of problems. I think in the end you will have 25 exercises forcing you to use different combinations of if, while, and for. And it is my view that the only way to improve your problem-solving skills, solutions with nested problem, is to train. You need to solve hundreds and hundreds of this type of problem. In the end, hopefully, they become easy for you. But training is what's needed. So, as I said earlier on, assignment 2 is time-consuming. Get started right away. Another example, requiring combinations of different control statements. And write a program, count A, that reads a string from the keyboard and then prints how many lowercase and uppercase A the string contains. A program might look something like this. Provide a line of text is the user instruction. And then I enter, all cars got the highest safety grading A. And then the program should respond with saying that the number of lowercase a is 3 and the number of uppercase a's is 2 in this sentence. You should count the number of a's. How do we do this? What is your idea? We have a text and we should count the number of a's in it. Well, the basic idea is from this text, pick every character one at a time, starting with the first one. And if it is one of these, if it is uppercase A, then we increase some counter by 1. If it is lowercase, then we increase another counter by 1. But we are picking out each character in the text one at a time and check them individually. And then in the end, once we have been through all characters, we are printing the results. We are printing NA and NA like this. So here the idea is that track of how many uppercase and lowercase a's you have seen. So please provide a line of text, user instruction here. No casting, we see it as a text. Then we initialize the 2 counters and set that NA and NA are both 0. And then this one, I haven't showed it before, I think. Iterating over all characters in a string is simple. All you have to do is a simple for statement that looks like this. For each character in text, it will give you all the characters starting from the first one at a time in the iterations. If it is this one, I increase this one by 1. If it is uppercase A, I increase this one. And I'm reading one character at a time here. When I'm done, when I've reached the end of the text, I say that the number of A is this one and the number of A is this one. Does it make sense? So note that iterating over all characters in a string is simple using a for statement. We have a text, and then we just say, for every character in the text, do something with this one, like this. You will do this 1,000 times, so it will. You will remember it. Any questions? How about the break? Let's be back here in about 10 minutes or more precisely, according to my, let's say at 11 o'clock, in 9 minutes.
Do we have switch statement?
No, Python don't have switch. They only have Okay, let's start again. We are done with for and while, although we will of course use it in many examples in what follows. Anyway, we will take a look at functions that are available for us as programmers. In this case, I'm using the random generator. I think I presented it in a previous lecture, didn't I? So the random function that generates an integer, in this case, in the range from 1 to 1000, the method the function randint belongs to a module random, and random is not available by default when we are running a Python program. So we must import it. Anyway, I asked the user number of random numbers. They give a value, say 100, and then I print the value 100 random numbers, and then I'm iterating 100 times. So I do n iterations. I'm asking, I'm generating. So this program will have 2 lines of output. The questions, number of random numbers, and then it will say random numbers, and then it will line up all the random numbers one at a time, like this. What we're doing here is not important. The important part is to see that we are using functions all the time. We are using input, we are using int, we are using range, we are using print, and here we are using randint as well. We are separating all functions into 2 categories. We have the built-in functions, input, int, print, and range in this case. They are always available. They are a part of the Java program. Any Python program understands these functions. And then we have the library functions that belongs to a certain module. In this case, randint belongs to the random module, and they are not available by default. We need to import them. So remember that we have 2 types of functions, the built-in ones and the library functions. And starting, I think, in the next lecture, we will also build our own functions, construct our own functions. There are a large number of built-in functions. Some of them we recognize, I guess. Print should be here somewhere. Print, well, input, all the ones, range, the one that I talked about earlier on here, and there are a number of different ones. Many of them we will not use in this course. But they are always available, and no import is needed. Here I'm showing a few of the common built-in functions. I introduce 3 variables, A, B, C, and give them some floating point values here. And then I said I'm printing the values. It will print the values, 1, -2. And here I start to use a few different built-in functions. We have a function called max, which of course picks out the largest of them. So this one will print 3.14, since it's the largest of this one. We have mean, the smallest one, absolute value that removes any minus sign and turns it into a positive value. So -2.2 is converted to 2. Round off, we have seen this one. It takes 3 and gives the closest integer to 3, which is 3.14. Closest integer is 3. We have the len command that measures the length of a string, and you will see that len also works for other structures like lists and things like this. It gives the size of something. And we have the type command. You can apply it on a variable or on a value, and it gives you, it tells you what type of value it is. For example, that A is a float and hello is a string in this case. Yes? round? No, no, it doesn't work. In 2 lectures from now, we will introduce a concept called list that can contain a number of values, and then you can apply round on each element in it. Yeah. Any problems with any of these functions? So max, mean, abs, round, well, they are manipulating numbers or picking out the largest or smallest one. They have the type conversion methods, float, int, bool, string. This one measures the length of something, in this case a string, and this one gives the current type of it. We are using these functions all the time. You have seen that we are using print a lot, but remember that mean and max is always available. You can give mean and max to any number of variables, and it will find the smallest or the largest one. Yeah.
We have a round off there, and it doesn't nothing suggests to how many points or
Yeah. I think in a previous lecture I showed that if I should have written round, comma, 2, it would give 2 decimals precision. But if you don't give any decimal precision, it will give the closest integer, rounding off. Another module that we will, well, sometimes use a lot is the math module. Basically, your pocket calculator, all the functions available in your pocket calculator is available in the math module. So I'm importing math here, and then I say, okay, give me pi, math pi, and then I'm calling here a number of functions from the math module. I'm printing pi. I'm dividing it pi divided by 3. You know, in radians, this is 60 degrees. So it will print 60. And you know that, maybe you don't know, but cosinus for 60 degrees is 0.5. And I'm basically doing a bit of computations here. Square root of 2, 1.2. Power, 4 raised to the power of 3. We can do this in another way in Python. How? 4 star star 3 is also. But this is a function that do the same thing. Floor and seal, what are they doing? Yeah, they are taking a decimal and they are rounding not to the closest integer, but always downwards. So the floor of P will be 3, and the ceiling of P will be 4. Floor and ceiling, it are upwards and downwards to the closest, to the next integer. This one is sometimes handy. And so floor and seal rounds off x downwards and upwards to the nearest integers. GCD stands for greatest common divisor. So what is the greatest common divisor between these two? The largest number that can divide both of them. It will be 5 in this case. What is the greatest common divisor of 16 and 32? It will be 16. 16 can divide both of them. Anyway, and this is just a small subset of all the methods that are available in math. There are cosinus, sinus, hyperbole, sinus, all the functions you need. Hundreds, I guess. What? What?
It's not available in Java.
Okay, not in the Java math. Yeah. Why is greatest common divisor? As a computer scientist, we think about something when we hear this problem. What is it? It's the world's oldest algorithm. A Greek, Euclides, put together an algorithm for how to compute this number 300 years before Christ. He solved this problem, how to find it in a numerical way. way ahead of computers. So Euclidean algorithm to find the greatest common divisor is considered to be the world's oldest algorithm for how to solve a problem. Okay, we can import functions from modules in different ways. This was the approach that I used earlier on. I said import math. Basically, I make the math module available. And then I said math square root and math greatest common divisor like this. I had to reference math in both cases. I could do it like this. I can say from math import square root and greatest common divisor. In this way, I don't need to start by saying math in this way. Or I can say from math import star, it make all functions in math available. And also in this case, I can, without using math dot, call the functions. Which one is the best? What?
The second one.
This one is not good. For math, you are making all the functions available, hundreds of them. And that means that these names are in some way in your namespace. And they can be mixed up with variables and things like this. So avoid this one. I said that this one is good if you should use a lot of functions from the math library. This one is good if you should only use a few functions from the math library. But both of them are basically okay. But if I know that I'm only interested in the square root function, then and I should apply the square root function a number of times, then I would go for this approach. Because then I avoid having to type math all the time. But just remember that there are two different options: import math or from math import certain functions. Yeah. Please speak up. I can't hear you.
Will you please repeat the difference between the first one, import only maths, and from maths import?
The difference is in this case, when we are using the functions from the module, we must start with math dot. In this case, we can avoid it. They are already available when we take this approach.
If we use the first one, so it's importing all the math functions.
Yeah, but we must start by referencing math all the time. Short names for imported modules. If I would like to generate two random numbers, I can import random, and I can say random, you give me a random in the interval 0 to 100, give me a random float in the interval 20 to 30. Import and then reference random like this. However, if I will do this a lot, and I think that this is a very long name, I can say import random as RD. I give it a short name here. So now I'm saying that I'm importing random, but I will refer to it as RD, and then I can just write RD down here. So I give it a short name to avoid writing random all the time. This is also an option. Later on, you will use a library called matplotlib, and this is a bit clumsy to write all the time. So people gives it a much shorter name, PLD. Yeah. Okay. Just tricks that you should know about. Terminate execution using exit. I have two versions of the same program. We are asking the user to input enter a positive integer. We're converting it to an int, and then if n is less than 0, we give an error message. Otherwise, everything is okay, and we do something here. The main program is down here. Another way of doing it is to use a function called exit that we can find in the sys module. So I am asking for a user input here. And then if n is equal to less than 1, I print an error message and I call exit. It should not be a dot down here. Sys exit just close down the program. So rather than having it as an if-else part here, I do an if part here and I close down the program, and then the main part of my program is down here without any indentation, not in the else part. Yes? No, they will figure it out, the interpreter. But this is the correct way. Sys exit is a function in the sys module. Sys stands for system, of course. So I often use this one if I have a bit of code and I find out that something is wrong, and I start to look for an error in the beginning of the code, and I don't want to run everything in the else. Then I insert a sys exit just to skip the remaining part of the program. And also, for example, when I'm solving the exercises in assignment 2, we have a problem, and then I solve the problem, and then I should start to clean it up. I have solved the problem down here. Okay, assume that I have solved the problem down here. Then I realize that I must check the input. So rather than indenting all my code down here, I insert one of these up here, just to avoid having to indent everything I've done so far in this way. But just remember it, if you want to close down your program at a certain point, exit is the one to use. Okay, another example. This used to be an exercise in the Java course earlier on. Anyway, stupid encryption. A very simple way to encrypt the text would be to just shift each letter one step in the alphabet. So I'm reading a text. Was it a rat I saw? And then for each character here, I just switch one step in the alphabet. So I translate A to B, B to C, all the way. And then down here, I said Z will be A. I closed the loop in some way. And I do the same for the uppercase letters. Like this. Is this a very good encryption algorithm? Do you think NASA or NSA would solve this secret mail that you're sending using this approach? They would solve it right away. So this is a very stupid or simple encryption method. But anyway, we are interested in writing a program, stupid encryption, that reads the lines of text and then encrypts it using this approach. So provide a line of text. Was it a rat I saw? It will shift all the letters one step and leave all white space and question marks as they are. Was it a rat I saw? What is it? A palindrome. What is a palindrome? It spells the same way backwards. Was it a rat I saw? It's the only non-trivial palindrome in English I know about. Ni talar bra latin is the only Swedish one I know about. Anyway, that's not part of the problem. Do you understand the problem? And the basic idea, if I see A, replace it with B. If I see B, replace it with C, and so forth, and leave these guys unchanged. There is a method called ORD that takes a character and gives you the ASCII code. There is another function called character that takes an ASCII code and gives you the corresponding character. So my idea is to take one character at a time here, convert it to its corresponding ASCII code, and then add 1 to the ASCII code, and then convert it back to the character. Because A to Z is lined up after each other in this ASCII code. So if I take the character lowercase a, convert it to an ASCII code, I will get 65. Then I increase it by 1 to 66, and I convert it back, it will get B on the other case. So for the main part of all characters, this is the approach I plan to use. However, this one is a special case, and this one is a special case where this will not work. So provide a line of text, and we are reading it string. The result, I start by saying that the result is an empty string. So this is the starting point. And then I'm iterating over all characters in this string in here. I also ask, give me your ASCII code. But then we have the different cases here. If the character is Z, then I add A to the result. That means the shortcuts. If it is uppercase Z, then I add uppercase A. If it is a lowercase letter, that means an ASCII code in this range, then I increase the range ASCII code by 1, convert it to a character, and add it to the result. If it is a lowercase letter, that means an ASCII code in this range, I do the same thing. I increase the ASCII code by 1 and turn it into a character and add it to a result. And these are non-characters, white space, question mark, and so forth. I don't do anything. I just take them and add them to the result. Is it understandable? I go through them. Was it a rat I saw? I take one letter at the time. And if it is one of these, I have a special, I know that they should be converted in this way. If it is an uppercase, I do this. If it is a lowercase, I do this. Otherwise, non-characters, I just add them directly to the output string. So I start with an empty string, a string of length 0. And for each character here, I add something to the result string. Doable? A bit tougher. Encryption. You are sending a love letter and you don't want your mother to read it. So then you take your love letter and you convert it to this code. Encryption. But it's just a programming exercise. You will see many exercises that you can actually ask, what's the purpose of this one? Why should I print a triangle using crosses? Just a programming exercise. This is an old Java test exercise. Before we had the course in Python, we had the course in Java. And the course in Java had a Java test. All students should solve a number of problems in 2 hours. And this was one of the exercises that we had for the Java test. Write the Java program square that first reads an integer higher than or equal to 3, and then prints a non-filled square of the type presented below. So the program should look like this. We have a user instruction, provide an integer 3 or higher, 5, and then I'm printing a square with 5 stars and 5 stars and 3 stars in between here. What's the purpose of this? None. It's just an exercise, a programming exercise to improve your programming skills. And of course, an error message should be given and the program should terminate if the user provided integer value is below 3. This is an old Java test exercise, but I present it here because the Python test exercises will look basically the same. This is the type of exercises. You will solve 3 of these exercises in 2 hours. read something, do something, solve a bit of a problem. How do I print this one for an arbitrary number n? So let's try to solve the problem in Python. Didn't I have it? What about in the back row? Can you read this one if I print something here? Okay, I go for that one. That's my favorite. Okay, read a number n, check that it's positive, check that it's large, 3 or larger, and if it's 3 or larger, print a square. How do we start solving this problem? Yeah, we can start with the input, but by now you know that I prefer to solve the problem before I start with anything like this. Or I just take n equals to 7 and think, okay, I should print a square for 7. We are printing line by line. We have 2 different lines. We have the top line and the bottom line. They are, in this case, 7 stars. And we have all the lines in between, which is a star, 5 spaces, and then a star. So my idea is to build these lines, these 2 types of lines, and then print the square in the end. So the first line, the topmost line, I can say here, topmost line, since it contains stars, I start with, I call it stars, and then I go for E in range n. I introduce a variable stars, and then it should be, I say stars to begin with is an empty string that contains nothing, but then I'm iterating n times.
Why is the range n, not n plus 1? So we must have 7 stars.
Yeah, so I will be the values 0, 1, 2, 3, 4. This is the simplest way. I'm not using I in any sense here. I just want to iterate n times. And this one is the simplest to iterate a certain number of times. If I should have used I to do something here, I would have to be a bit more careful. But now I just want to do something 7 times. So I'm adding a star to this one 7 times, and I'm printing it. Let's see how it works. It prints 7. So this is the first line. Intermediate. Let's call it space. And we know that this one will start with a star. And then for E in range n minus 2. Space plus minus
Equal instead 0.
plus equal. Do you agree that I have tried to construct an intermediate one which starts with the stars and ends with the stars and then n minus 2 spaces in between? Okay. Okay, now I have the two different types of lines, and I should print the square. What should I print? Stars, and then n-2 spaces, and then stars one more time. So I print stars for E in range n-2. I print the stars, I print n-2 spaces, and I print stars. Let's see if it works. First, I printed the stars line, then I printed the space line, and then this is my square. And it's 7, and it's 5 of these. I think it looks okay. Did you understand? Yeah. We know that the square should be of size 7 in this particular case. But in general, it contains two different lines. It should be an n times n square. It contains two different lines. One with only stars, one of these, and it should be 7 of them. So for E in range n to n, here I'm iterating n times, adding. The intermediate line, the one starting with a star, having n-2 spaces and a star. If n is 7, we should have 5 spaces, n-2. So in this case, I start by adding a star to the line. Then I have n-2 spaces, 5 in this case. And then I add the space in the end. So n-2 is the number of spaces for a given square of size n. And then now we can remove this one. We can remove this one. And then down here, I'm just printing the square. It starts with a line of only stars. It has n-2 lines. That is the space type, and then it has one more of this type. Okay. We are almost done. I think at this point, I feel rather comfortable. In some way, we have solved the problem now. Now we should do the boring standard stuff. We should give a user instruction. Input enter integer larger than 2. And then to make it good looking, we insert a colon on a space here. What more? I think we can insert an extra line here. Just to have a bit of space before we start to do the printing. What more should be done? We should check that the input value is correct. Now we are in the situation that I described earlier. I have done a bit of programming here. I could now insert an if statement, say, if n is less than 3, if n is less than 3, print an error message, else we do this entire code. But rather than indenting everything in here, I can just say, if n less than 3, you can go here and say, boxes, We can give an error message. Print, please follow instructions. Exclamation mark, I think, is appropriate here. And then we can say sys exit like this. What? I can. Okay, I haven't tried it. And he informs me here that you could add, if I understand it correctly, you could add an error message in here, and that will be printed before it stops, I guess. Let's give it a try. Wait. Yeah, it works. What did you say? I can't hear you.
The instruction word you miss.
Enter.
No, yeah, here.
Ah.
It's not important.
Are you happy? Good. So we learned something today. Actually, it means that I can take this one, cut it away. Like this, in this case. We have a user instruction. I can see you're upset. Enter integer larger than 2. It's a user instruction. If n is less than 3, we are closing down the program immediately with a comment, please follow instructions, and then if it is not this case, then we complete the rest of the program and print the stars like this. Let's give it another try. Oh. Ten. It looks like 10. Questions related to this problem? This is a typical Python test problem. Yes?
Why do we use
Here. This is a code shortcut. N equals n plus 1. This is exactly the same thing as n plus equals 1. So it's a shortcut. So what we are saying here is actually space equals the old space plus the string. Other questions? Okay, that's all for today. Assignment 2 is available, and you have plenty of exercises related to this lecture. So go home and start programming, and then go to the tutoring sessions, and if you have any problems or questions. Or post a question in Moodle, or in Slack, sorry. Okay. Yeah, see you on Wednesday.
录制已停止。
What do you say? Thursday for the English group. Yes, Wednesday for the Swedish group.